Very good evening, all. Very good evening, all. Coming. Coming. Good evening. Good evening. 1 second, please. So, 1 second. Yeah. Starting. Come on. Come on. Good evening, all. कॉपी में मत लिखना. Good evening. Good evening. 1 second, please. Yes. बहुत लोग आ गए. चलो स्टार्ट करें. Shall we start? Hope everything is fine. एक बार बोलो. Is everything fine? बोलो एक बार. हाँ जी. Then we can start. एक सेकंड. 1 second रे. अरे यार. बोलो एक बार. It's on multi channels. Yes. Great. चलो सब क्लियर है. वंडरफुल स्टूडेंट्स ऑफ इंडिया. चलो, लेट मी टेल यू व्हाट द प्रोग्राम इज. डियर स्टूडेंट्स, if there is any problem, just call me. हमारे तनुज बाबा के पास नंबर है, तो कॉल कीजिए if there is any problem, because I'll not be looking at your comments, because if I start looking at comments, the flow will be lost and the rhythm will be broken. So I will not focus on your comments. I will focus on your comments when I ask some questions. So if there is any problem with network or if there is any issue, just call me on this number. So I think that this is enough. Okay, नहीं दिख रहा रे, कैसे दिखेगा रे? Yes. So I'll get back immediately. Chalo. Okay na? Let's start. Chalo, let's start. My dear students, I'm starting. Shall we start? Okay. Chalo. Okay. Yes, everything is fine. Now, I will not focus on your comments, please. First request is, इसको थोड़ा साइलेंट कर देंगे सर. बीच में मुझे देखना पड़ता है क्योंकि इस फ्लो होगी सब. ओके, वंडरफुल. चलो, shall we start? Okay. This is a revision course on strength of materials. Some of the students suggested me, sir, you take a particular chapter, you cover important theory and associated questions. So I have a plan to do in the same manner. I will take a particular chapter, I will cover theory, and after theory, I will cover some very good questions. These questions which I have not done in our regular classes, or earlier I took some of the questions on YouTube session. So important questions. So please, my dear students, I am not going to do those questions which we have already covered. So let me tell you the plan. The plan is I will be covering theory. Once I complete the theory on that particular chapter, I will do new questions which I have not covered in our regular plus classes, and some questions I have solved in YouTube, some important questions. They are also not touched. Totally new questions. For example, थोड़ा confidence gain करने के लिए, let me show you what I have planned for you. What I have planned for you. 1 second, please. 1 second, please. Beautiful questions. एक बार देख लेना. Beautiful questions like this. Compound bars, composite bars. सारे नए questions I am doing. Okay? चलो. So the sequence is, what I am trying to do is, dear students, एक second रुकना. रुको जरा. हाँ. एक second. Last slide. Right. तो क्या ये प्लान ठीक लगा आपको? एक बार बोलो. Is this plan okay, my dear students? Is this plan okay? You are not saying anything. If you say okay, then I'll move ahead. अरे मैं लास्ट में एक ग्रुप बनाएंगे रिवीजन कोर्स का, उसमें डाल दूंगा सारे. Is it okay? Is it okay? My dear students, is it okay? अब without wasting time, as this is the first class, we have wasted around 3 to 4 minutes. No problem at all. Now, let's check carefully. It's a humble request to all of you. Do not focus on comments. Just focus on class. मैं तो comments की तरफ देखूंगा ही नहीं. If I ask you some questions, then only I'll see comments. At the end of the class, if you have any doubts, you can ask those doubts. I will answer to those questions. So don't worry. In the meantime, अब देखते वही नहीं करेंगे हम. Okay ना? चलो. एक बार लास्ट में okay sir बोलो. Start करेंगे. बोलो एक बार okay sir बोलो. बोलो रे. Right. Now, this is a revision course on strength of materials. Revision course on strength of materials. And one more thing, my dear students. And one more thing. I will not cover everything in a detailed manner. That I have already done in my regular plus classes. So important points, important theoretical points I'll discuss after covering theory on important theory. I will not give you all derivations, all details. No, just a quick revision. Just a quick revision. And please don't think that, sir, ऐसे ही पढ़ाते क्या regular classes में? This is not a regular class. The assumption is, the way we make assumptions in strength of materials, I'm making same assumptions here also. The assumption is, you have already covered the syllabus. You have already covered the syllabus. You know basics. So now what are we doing in this? Just a quick revision of theory, then good questions. Quick revision of theory, good questions. Chapter, revision, good questions. So today I'll talk about the first chapter, that is stress, strain, elastic constants, Poisson's ratio. Okay, all these I'll be discussing. Chalo. Achhe questions liya sir. I have tried my level best. Okay, chalo. Now, I will not tell you what is, for example, what is mechanics, how mechanics is classified, rigid body, deformable body. Ye sab nahi sir, because that is not of our interest. Straight away, theory, important theory, refreshing that theory, associated questions. And if some theory is missed, then in questions it will be covered. But first, theory. So I am assuming that you have covered the theory. Is that fine? Chalo, aage badhte hain sir. Dear students, you know, our strength of materials is nothing but it is the mechanics of deformable bodies. And here we are talking about mechanics of solids, because we will be studying fluid mechanics under the chapter mechanics of fluids. Now here in engineering mechanics, we deal with rigid bodies. So what is a rigid body? So on the application of load, the distance between any 2 points on the body or in the body, it doesn't change. It is fixed. But for a deformable body, under the action of load, there is a change in the relative position. So rigid body is just an idealization. So to make things easier, and if the deformations are very small compared to dimensions, we approximate it to be a rigid body, and thereby our life will become easy in engineering mechanics. But in fact, actually, the bodies are deformable. So therefore, we are studying in strength of materials the mechanics of deformable bodies. What do you mean by mechanics? Means action of forces. Under the action of forces, how bodies are behaving. These things we are studying, my dear students. Now, the first thing is, straight away I'll go, without wasting time, straight away I'll go. What exactly is a load? Load is an external force or movement. Don't think that load means only force. It can be movement or it can be force. And there are different types of loads. First one is classification is based on the direction of loading. Based on the direction of loading, we call the load as, my dear students, axial load. That is, if the load is parallel to the axis, longitudinal axis, this axis, then we call it as axial load. If that load passes through the centroidal axis, if it passes, then we call it as pure axial load, pure axial. And if the load is parallel to the axis, but not passing through this, if it is somewhere here, we call it as eccentric axial load. Still, it is axial load, but it is eccentric. And depending on the direction of loading, the load is also known as transverse loading. When the load is perpendicular to this, we call it as transverse loading. For example, let us take this member. My dear students, let us take this member. These are the centroidal axis, and if the load is passing through this transverse, if the load is passing through this centroidal axis and perpendicular to this longitudinal axis, it is the transverse load. If the same load is somewhere here, of course perpendicular to this axis, but it is somewhere here, we call it as eccentric transverse loading. So based on the direction of loading, we categorize the load into axial load and transverse load. So in this first chapter, we'll be talking about axial loads, and that first thing is, we are not talking about any bending. We don't know what is bending, let us suppose. So we are talking in this chapter pure axial loads. What do you mean by pure axial loads? For example, if this is the member, so when the load is passing along the axis and passing through central axis, it is a pure axial load. So in this chapter, we will be studying about pure axial loads, leave it. So no problem at all, my dear students. Now, we have different categories like loading based on dimensions. What do you mean by based on dimensions? The load based on dimensions, it is based on the length, it is based on the area, it is based on the volume. So for example, we have weight, gravity, weight. So it is acting throughout the volume. So therefore, it depends on the volume. Similarly, if I take, for example, area, pressure force, pressure is acting on the area. And you know, drag force, you have already studied drag force. It is also dependent on the area. Greater the area, greater is the drag. So similarly, we have based on length, surface tension. So surface tension is force per unit length. So based on the dimensions also, we can categorize the load. Now, the loads are also static and dynamic loading. The loads are also static and dynamic loading. Let's see what is a static load. A load is said to be a static load when the magnitude, direction, and point of application, these three are very, very important. When the magnitude value, direction, and point of application, if it does not vary with time, it is known as static loading. For example, please understand carefully. This is the board, let us say. Now it is kept like this. I am not using this board, let us say, for 1 year, 2 years, let us keep it like this. And whatever the load is there, its weight is not changing with time. On the bolts, whatever the load is coming, the load is exactly the same. The direction is exactly the same. The point of application is also same. So dead weights, these are nothing but static loads. The design of static loads is rather easy. But what is dynamic loading? When any one of these or all the three change with time, it is known as dynamic loading. So hope you are following. Is it okay? It is known. What is he saying? Sir, please bilingual. Yes, I'll take in both languages. Don't worry, Re Baba. Language is not a barrier. Please just listen. चलो अरे यार आप language से थोड़ा disturb मत होना sirs. Please. And please don't disturb the flow. Now, design of dynamic loads is a bit difficult, which I had discussed in machine design. That is fluctuating loads, fatigue loads, all these we have discussed. But in strength of materials, we'll be dealing with static loads. No problem at all. Now, observe here. So what is static load, my dear students? A load which does not vary in magnitude, direction, and point of application is our static load. No problem at all, my dear students. Ab dekho. Now, observe here. So under dynamic loads, we have, my dear students, under dynamic loads, we have different loads like, please listen, impact loads, sudden loads, shock loads. Sudden loads, impact loads, and shock loads. These come under dynamic loadings. Let's see what is a sudden load. Sudden load is the load which comes suddenly, but not from height. For example, here the height from which the load is coming is 0. For example, there is a railway track. On the railway track, listen carefully. On the railway track, the train is moving. On the railway track, the train is moving. And please observe. So, the load will come suddenly, but not from some height. Just it passes. Just it passes. Just it passes. So, for sudden load, the height from which the load is coming is 0 or approximately 0. For example, let's see in the case of brakes. For example, if you see, let this be drum and let this be the shoe. And if you see the distance between this, it is very negligible. And suddenly when you apply brakes, the load is coming on this drum suddenly, but from what height it is coming, almost negligible, almost 0. It is brake is an example of what? Sudden load, sudden load. Now let us see what is a shock load. Shock load is the rate of loading is so high. The rate of loading is so high. मतलब the force will come, इतना तेज आएगा और कम समय में आएगा. It will come so fast in a very short time. But unfortunately, shock load का कोई prediction nahi hai. You don't know. For example, tsunami. For example, bomb blast. So when the bomb, like when there is a blast, you know the forces are so high in short time. But for example, the particles from the bomb, they come and hit maybe at different heights. You know, you don't know, but you cannot predict it. They are shock loads. Then what is impact load? My dear students, impact load is a improvised version of shock loads. ये क्या है sir? What do you mean by that? In shock loads, the rate of loading is high. In impact loads also, the rate of loading is very high. In both, the rate of loading is very high. But it is an improvised version. Improvised version. What do you mean by improvised version? इसका मतलब क्या है sir? For example, हमने टेस्ट करते हैं 4P टेस्ट, इजो टेस्ट. इधर देखो, हैमर लिए और मार रहे. आपको पता है, you know that you are going to hit the nail. For example, there is a nail. You know you are going to hit. And how much force is coming? The load is coming so fast in very short time. So shock load ka improvised version is what your impact loads. Impact load mein pata hai aapko. So when are you going to hit? But in a small time, large force is coming. So we have seen the different types of loadings. Now, my dear students, in strength of materials, we make some assumptions. Homogeneous material, isotropic. Homogeneous means throughout the volume, the properties are same in a particular direction. So please observe, for homogeneous material, the property does not depend on the point. At all points throughout the volume, the property is same in a particular direction. Then isotropic. What is isotropic? Properties are same in all directions at any given point. So for homogeneous material, properties are independent of point. Throughout the volume it is same. For isotropic, properties are same in different direction. Maybe X, maybe X, maybe Y, maybe Z. In all directions at a given point, properties are same. So luckily, most of the materials are homogeneous and isotropic. Even if they are not homogeneous and isotropic, we make that assumption of homogeneous isotropic. For example, wood, crystals, they are not isotropic, but we make our life very simpler. So in strength of materials, the complete continuous assumption is the material is homogeneous and isotropic. We assume the material to be homogeneous and isotropic, homogeneous and isotropic. Is this space okay, sirs? Is everything clear? Is everything clear, my dear students? क्या ये सही क्लियर है? सब लोग एक बार बोलो, क्या और थोड़ा फास्ट जाओ या स्लो जाओ? आप बताइए. Is everything fine? Wonderful, 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 wonderful. चलो. Now, my dear students, let me start with this. ये थोड़ा बेसिक इंट्रोडक्शन होगा. स्ट्रेस. जिंदगी में हम every time we use this word stress, 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 stress. Now observe here. Now, let us take a member and I have applied a load of 100 Newton. I have applied a load of 100 Newton and let us assume this to be frictionless and it is moving. What is the stress? Dear students, what is the stress? एक बार बता दीजिए. What is the stress? Anyone? What is the stress? What is the stress? अरे यार कुछ नहीं बोल रहे आप. Wonderful, sir. 0. अब आप बताइए. Now have a look at this. Now have a look at this. वो थोड़ा यहां ले लेंगे. एक सेकंड प्लीज. Let us not waste time. Time is very important now. Dekho, I will cover important theoretical points and beautiful questions. And please, those who are serious, without wasting your time, I will cover chapter new questions, not covered in class, not covered earlier on my YouTube classes. Okay, chalo. Now, for example, let us take this. I have applied a load of 100 Newton here, and there is a load of 30 Newton here. And let this area on which the load is acting, let this area, let it be 1 unit, 1 meter square, whatever it may be, 1 mm square, whatever it may be, 1 unit. Now, is it subjected to any stress? Ab aap bataiye. Is there any stress? Ab bataiye, sir. Yes, definitely. Ab dekho, sir. Out of this 100, 30 is resisting this. Out of this 100, 30 is resisting. So what is the net force in this direction? It is 70. So with that net force, there will be acceleration of the body. But this side 30, this side 30, there is this 30 is resisting this. Whatever I have applied, out of 100, 30 is resisting. It's something like this, my dear students. I'm holding your finger and you are coming with me. I'm holding your finger and you are coming with me. So happily you are coming with me. There is no restriction. There is no constraint. So you don't find any pain in your finger. But now I'll hold this. I'll hold this. I'll hold this. I'll not allow it to move. Now I'll pull this. I'll pull this. You just see. Now I'll pull this. I'll hold this finger. It is constrained. It is restrained. Now it is not moving. Earlier it was moving like this. So no pain. No pain. Now it is constrained. Now you apply. You apply. You are finding the pain. You are finding why the pain is coming. Because it is constrained to move. It is restrained to move. So therefore, whenever a member is restrained, whenever it is constrained, there will be pain in the body. That pain we call it as stress. So मैं हमेशा stress को pain से compare करता हूं. I generally compare stress with pain. So if the pain in the body is more, it is not a good sign. You may break down. So similarly, if the stress in the body is more, it may fail, which is not good for the material. That's why there is a need for us to study these stresses. So the main aim of SOM is 3S, triple S. Stress, strain, stability. Stress, strain, stability. So analyze what is stress, see what is strain, and see the stability of that member of that structure. So it is based on triple S, strength, that is, stress, strain, and your stability. Wonderful, sirs. अब आगे बढ़ते हैं. Is it okay? आगे बढ़े. बोलो, sirs. Please, एक छोटा सा request है, sir. If you are attending, attend completely. Otherwise, don't attend. I'm not forcing anyone. चलो, let's proceed, sirs. Now, definitely there is a stress. और एक बात है, sir. एक काम करते हैं, sir. We'll do one thing. So, to have a better understanding, let's do like this. There is a member, my dear students. Observe, आराम से. There is a member and it is kept on the table. जो भी है यहाँ रखा है. You heat it. There is a member and you heat it. What will happen? Most of the members, when you supply heat, it expands. So after some time, it may become something like this. Now tell me, is it free to expand or was there any constraint? Is it free to expand or was there any constraint? It is free to expand in all dimensions. Whenever the member is free, इधर देखो, मैं हाथ पकड़ लिया, freely आप आ रहे हैं, so no pain in this. So therefore, there is no stress. But now originally, the member was like this. So originally it was like this. Now it is free to expand. So there was a question in GATE twice. A block is kept on the table. And it is supplied. Heat is supplied to the block. The stress in the body is It is unconstrained. It is not constrained. The stress in the body is what? Zero. Whenever there is no constraint, when the member is free to either expand or contract. For example, इसको cool करो थोड़ा. If you cool it, क्या होगा? वो contract होगा. And it is free to contract in all directions. So when it is free to expand or free to contract, there is no constraint. When there is no constraint, there is no pain. मतलब freely, mind को भी वैसे करो आप. Free thinking जब है, without thinking about others. It is also a life lesson. Without thinking about others, freely when you go ahead with your subject, freely when you learn the subject, you will not be stressed. We call it as passion, and you study for 12 hours without any pain. But if you start thinking, that fellow is studying more, that fellow has completed that topic, this fellow, all these are constraints in mind. When there is a constraint, you don't enjoy freely. Therefore, you get stressed up. That's why आज एक बहुत बढ़िया बात सीख लिए हम. अगर जिंदगी में स्ट्रेस नहीं होना चाहिए, फ्री रहो फ्रॉम ऑल थिंकिंग्स, फ्री फ्रॉम कंपेयरिंग अदर्स. इज इट ओके? तो बता लिए एक बार. बोलो रे, क्या स्टूडेंट्स है रे बाबा. आपको पढ़ाने से मजा नहीं यार? मजा नहीं आया, मजा नहीं आया, है ना? बोलो बोलो. चलो आगे बढ़ते हैं सर. चलो लेट्स प्रोसीड. नाउ विल डू वन थिंग. Please observe these expansions or contractions, these change in dimensions, we call them as deformations. Expansion, contraction, these change in dimensions, we call them as deformations. एक काम करो सर. Now, same member, let's constrain it in x direction. This is the block. देखो, let us constrain it in x direction. Now you tell me. It was initially free to expand in x direction. Now you have constrained the deformation in this direction. Later on, I'll be telling you these deformations are linked to strain. Strain is nothing but change in dimensions, which I'll be discussing a little later. So these deformations are related to strain. I'll be telling you, don't worry. तो यहां पे किसको कंस्ट्रेंट किए सर? इन एक्स डायरेक्शन किसको कंस्ट्रेंट किए? डिफॉर्मेशन. इट वाज नॉट फ्री टू earlier it was free to expand, no stress. Now it is not free to expand in this direction. तो किसको कंस्ट्रेंट किए? डिफॉर्मेशन और स्ट्रेन को कंस्ट्रेंट किए. जब स्ट्रेन को कंस्ट्रेंट किए, स्ट्रेस उभर के आया है. When the strain is constrained, when the deformation is constrained, स्ट्रेस आ रहा है. पहले नहीं था. Earlier it was not there. So when the deformation is not constrained, when the strain is not constrained, when it is free to expand, there is no stress. So what is the reason for stress? Constraining the deformation, constraining the strain. So strain is the cause of stress. So that's why we know, my dear students, यहाँ पे cause, यहाँ पे effect लेते हैं. We take cause and effect. So what is the cause of strain? What is the cause? Strain is the cause and stress is the effect. That's why stress is taken on y-axis, and please look at independent is taken on x-axis. Because of this it is coming, so dependent is taken on y-axis. This can be asked in interviews. Is it okay, my dear students? Is it okay? मैं आगे बढ़ सकता हूं सर? आगे बढ़ सकता हूं सर? बोलो बोलो. Very good, sir. So now let's see what exactly is stress. So whenever a member is constrained, when a member is constrained, stress is developed. Stress is developed. So what is the cause? Whenever deformation or when strains are constrained, the member is subjected to stress. So stress is developed. चलो कोई बात नहीं. अब देखते हैं सर. What are the different types of, now what exactly is stress? Look at carefully. I told you, my dear students, when it is constrained, when I am pulling, there is a pain in the finger. That pain is your stress. So I have to quantify that pain. I have to quantify that pain. Matlab, I have to give some magnitude. I have to give some value. Look at. So therefore, now physically you have felt what exactly is stress. Physically you have felt. Now let me explain mathematically. Physically, stress is nothing but your pain. Physically, stress is nothing but your pain. Now, for example, let us take a member. Let me apply force P. Let me apply force P. इधर देखना. Now it is in equilibrium. It is in static equilibrium. So let us cut and see the section XX. So observe here. Now this is the external force, and that external force we call it as load. This is the load. This is the load. External force. This is the load. If I draw this, will it be in equilibrium? Absolutely no. Absolutely no. Means there has to be some internal resistance to this. Because why there is a resistance? Because it is constrained. Because unlike this, for example, unlike this, there is no constraint. So therefore, there is no internal pain, internal resistance. But it is constrained here. You have fixed it here. So when I am pulling it, it is fixed like this. It is fixed like this and I am pulling. So therefore, there is a constraint. So therefore, their internal resistance is developed to this external load. And this internal resistance, and moreover, you know, it has to be in equilibrium. For equilibrium, whatever the external load is applied, it is in static equilibrium. So whatever the external load is applied, and this should be exactly same. And this we call it as internal resistance to this external load. And you know, it is in equilibrium. So therefore, this will be equal to P. So stress is defined as the internal resistance offered by the material acting per unit area. On what area it is acting? For example, इधर देखो रे. So for example, my dear students, need not be of this shape. It can be any shape. Let this area be A. Let this be P. And if you cut, you will be seeing something like this. For example, this is the external load. On this area, there is an internal resistance, and that per unit area, that internal resistance, which is nothing but here P, per unit area, and that is known as your stress. So please note down that it is the internal resistance. It is the internal resistance. And stress is of two types. One is normal stress. Normal stress is nothing but the stress which is perpendicular to the plane. For example, here on this plane, the load is like this. So on this plane, if you see on this plane, the resistance is to this plane, it is perpendicular. To this plane, it is perpendicular. And that perpendicular loads per unit area, matlab internal resistance per unit area, when it is normal to the plane, you call it as normal stresses. Normal stresses, look at my dear students, the load can be like this also. The load can be like this also. For example, if you observe clearly, if this is the plane, it can be inwards into the plane or it can be out of the plane. When the load is out of the plane ke perpendicular or bahar, we call it as tensile. When it is inward, when it is plane ke inward, it is known as compressive. But both are normal stresses. Normal stresses. And what is the unit? You know, resistance is Newton, area is meter square. It can be Newton per meter square or it can be Newton per mm square. It can be kg force per millimeter square. It can be centimeter square. We can have so many units for this. So there is no need for you to worry. Chalo, aage badhte hain. Now there is one more type of stress. What is that stress? It is a shear stress. For example, let's see what is a shear stress. Let us take a member like this. Okay, and it is fixed here. Yes, it is constrained. It is constrained. Now, let me apply a load like this. And please tell me, this load is, how is this load applied? This load is in this plane. Is plane ke andar hai or parallel to the plane. So, because of this, actually, if there is no constraint, it will move freely, but there is a constraint. It cannot move. So, therefore, resistance is developed in the opposite direction. So, therefore, if this is, my dear students, एक second. If this is the applied load, there is a resistance like this. And for equilibrium, these two should be same. And thereby, this internal resistance on this area, and that is your stress. And this stress, we call it as shear stress or transfer stress. Shear stress. So, dekho, tangential. It is tangential. Shear stress, shear stress. Up to this, is it okay, sir? Up to this, is it okay? Up to this, is it okay? मैं आगे बढ़ सकता हूँ? No. Okay, no problem at all. No problem at all. Absolutely fine. Okay, okay? Okay ना? थोड़ा पेस बढ़ाओ या फिर ठीक है? थोड़ा पेस बढ़ाओ या इतना ठीक है? थोड़ा fast. Very good, very good. If you want me, yes, wonderful students, because wonderful students of India. अब देखो, please listen. चलो ये होगा. So stresses are of two types. Normal. So I'll designate normal stress with sigma and I'll designate shear stress with tau. Okay, no problem at all. No problem at all. यहां तक किसी को कोई प्रॉब्लम नहीं है. यहां तक किसी को प्रॉब्लम नहीं है. Now observe here. Is stress a property? Absolutely no. For example, let us take a member. Is it a material property? एक बार चेक करते हैं. same dimensions, matlab there is A, there is B, same dimensions, dono exactly same, and the cross section is also exactly same. Geometrically both A and B are same geometrically, but the only difference is material is different. Say this is made of copper, this is made of steel, let us say. Material is different. Now I'll apply 100 Newton. यहाँ पे भी I'll apply 100 Newton. And this area, let it be 5. Let this area be also 5. I'm least bothered about units as of now. You tell me what is the stress in this. You tell me what is the stress in this. You tell me what is the stress in this. You tell me what is the stress in this, my dear students. So इसमें क्या होगा? It is 100 by 5. That is internal resistance will be 100 by 5. इसमें क्या होगा? It is 100 by 5. So that means it is 20. It is also 20. So now you tell me, is it okay? 20. Wonderful, sirs. Wonderful. So now you tell me, is this stress depending on the material? No. So whenever I say property, it is exclusively for a material. But materials are different, but still the value is same. Means stress is depending on what? What is the load? What is the area? So area is same, load is same. So stress is not same. So therefore stress is not a property, but strength is a material property. Sir, ये strength क्या है? इधर देखो. Look at carefully. This material can bear, my dear students. So therefore, please understand. एक second रुको. एक second, please. Is everything fine? सब ठीक है ना? एक second, please. एक second, please. एक second. Yes, yes, yes. सब फाइन है ना सर? तनुज बाबू, बाबू तनुज, नो प्रॉब्लम ना? चलो चलो आगे बढ़ते हैं, आगे बढ़ते हैं सर. 1 second please, 1 second. Yeah, wonderful students of India, wonderful students of India. अरे यार आपके चार्ट्स नहीं दिख रहे मुझे, एक बार देखेंगे. Yeah, great students of India. अब आगे बढ़ते हैं. चलो चलो. Now देखो, this is material A, this is material B. Let us apply 100. Let us apply 100. Let the area of this be 5. Let the area of this be 5. Listen. Let us assume that if I apply 100, it fails. For example, if I apply 101, it fails. Just imagine, because material is different. Definitely, it's something like this, my dear students. One student can study for 10 hours. One student can study for 4 hours. It is his personal capacity. That is his property. So therefore, strength is the maximum stress. कितना maximum ले सकता वो? Suppose एक मान लो ये 100 लेगा. Say this is taking 100. If I put 101, it will fail. So what is the strength? It is 100 by 5. And इसका मान लो, if I put 500, it will not fail. It will not fail. If I put 501, let us say, if I load it with 501, it is failing. So maximum it can take is 500. So 500 by 5, it is 100. So the strength of this material is 100. The strength of this material is 20. So stress is not a property, but strength is a property of material. Is it okay, my dear students? Is it okay? Sir, in my strength of materials, I'll be loading within elastic limit. अभी elastic limit ये सब देखेंगे. अब तक यहाँ तक clear है सर? अब देखो. Now, please understand, my dear students. Dear students, एक बार देखना. Please understand. Please understand. Whenever a member is loaded, you can observe two things. Let me repeat, sirs. Whenever a member is loaded, you can observe two things. अरे यार मैं क्लास में हूं यार. Useless fellow. Unnecessarily, why do they disturb? Already call cut कर दिया. Now, let us suppose this. देखो एक बार. Now, when the member is loaded like this, what is your expectation? मतलब, what are your guesses? The length will increase. So, it will be something like this. and when the load is applied like this, it may deform like this. Both are deformations, sir. In one case, you are observing change in dimensions. Length is increasing, the y dimension is decreasing, maybe diameter, okay, maybe the depth, it is decreasing, length is increasing, but the cross-sectional shape is not changing. Understand carefully. For example, if there is a normal load, after some time, it may become like this. If it is like after some time, it may become like this. So you tell me, what type of load is this? Normal. So normal loads or normal stresses, they result in, ये बहुत इंपॉर्टेंट पॉइंट है सर, दिस इज अ वेरी इंपॉर्टेंट पॉइंट सर. यहां से क्वेश्चंस आएंगे. क्या क्वेश्चंस है? कंफ्यूज करने के लिए आपको शेयर देगा. तो बिकॉज ऑफ शेयर देयर इज अ चेंज इन शेप. सिंपली क्या होगा मैं बताता हूं, सुनो इधर देखो. सिंपली क्या होगा, ये लाइन इधर आएगा, दिस लाइन विल कम दिस साइड, ये जो है ना इधर शिफ्ट होगा, और ये लाइन इधर आएगा. तो यू डोंट फाइंड एनी चेंज इन डायमेंशंस, you find change in shape. So which type of loading or which type of stress is responsible for change in shape? It is shear or tangential stress. Just ये ऐसा shift होगा. So there is a deformation. इसको भी deformation बोलेंगे, इसको भी deformation बोलेंगे. Both are deformations. But one deformation is resulting in change in dimensions. Other deformation is resulting in change in shape. So which confuse करने के लिए आपको पूछेगा, a member is loaded by a normal stress of so and so, shear stress of so and so. What is the change in volume? So to confuse you, he has given shear stress. Don't touch that shear stress. Just take normal stresses which are responsible for change in dimensions. So golden point यहाँ पे क्या लिखना है? The golden point that you need to write is normal stresses result in change in dimensions, and shear stresses, they do not result in change in dimensions, but they result in change in shape. Up to this, is it okay, sirs? Up to this, is it okay, sirs? Up to this, is it okay? पुष्पेंद्र दुबे, इंजीनियर अमित, विशाल, वंडरफुल. अब आगे बढ़ते हैं सर. वंडरफुल. चलो आगे बढ़ते हैं सर, कोई दिक्कत नहीं. ना इधर देखना सर. अब देखो. Now let's define what exactly is strain. First हम define करेंगे strain. Strain is nothing but deformation. So the deformation is of two types: change in dimensions, change in shape. Change in dimensions, change in shape. Change in dimensions, change in shape. अब देखो, first I'll talk about normal strain. Normal strain, and I designate it with epsilon. The normal strain arises due to normal loads, which result in change in dimensions. So देखो एक बार, it is nothing but change in dimension to the original dimension. यहां पे सर हम तो कहीं पे पढ़े थे change in dimension to the instantaneous. Wait sirs, first I will talk about engineering stress, engineering strain, or conventional stress or conventional strain, or nominal stress or nominal strain. So first I'll talk about this, then I'll go for engineering stress, engineering strain. और इस पे अच्छे क्वेश्चंस भी लिया हूं, और रेजिलियंस, टफनेस पे अच्छे कुछ रेशियो पे क्वेश्चंस भी लिया हूं सर. आई हैव टेकन सम वेरी गुड क्वेश्चंस. लेट मी कंप्लीट द थ्योरी फर्स्ट. इज इट ओके? चलो आगे बढ़ते हैं. चेंज इन डायमेंशन टू द ओरिजिनल डायमेंशन, एंड व्हाट इज दिस नोन एज नॉर्मल स्ट्रेन. Normal strain, what does it mean? For example, and it is dimensionless. Why? Because देखो यहां पे कोई dimension, this is ratio of same quantity, length by length, so no dimension. Very good sirs. अब आराम से देखो. Similarly यहां से देखो एक बार, suppose the original length of this is 10 centimeter. Now I have applied a load like this. So because of this load, let us say the member has deformed or elongated. Say this is 1 mm, this is 1 mm. So what is the change in length? So original length was 10. So original length was 10. So can I write 10 centimeter as 100 mm? Yes, I can write it as 100 mm. This is the original length. And what is the change in dimension? It is 1 mm. So therefore it is 1 by 100. So strain is dimensionless. So strain is, or if you can express this in percentage. If you want in percentage, I can write it as 1%. Strain is 1%. क्योंकि जब मैं malleability, brittleness, ductility ये सब पढ़ूंगा तब percentage में बताऊंगा strains को. Okay? So around 1% इस केस में. So these strains are nothing but normal strains, normal strains, normal strains. Wonderful. So measuring normal strain is not like a problem. Normal strain is not a problem. That's why when we go for strain rosettes, normal strains can be measured, but shear strains are calculated. अब देखते हैं sir. And please, one more thing, my dear students. Strain is a fundamental quantity. What do you mean by fundamental quantity? I can measure easily. I can measure easily. So, but stress is not a fundamental quantity. And one more thing, my dear students. For example, stress, एक बार देखो, carefully देखना सर, ये बहुत important point है. This point is very, very important. For example, there is a load like this and say the stress is, for example, normal stress, normal को मैं sigma से designate करूंगा. Let us say it is 50 Newton per mm square, and Newton per mm square is also megapascal. Let us say it is 50 megapascal. Wonderful, sirs. Let's see, is it a vector quantity? आराम से देखो सर, मैं अभी प्रेशर स्ट्रेस के बारे में डिटेल में क्लास में बताया था, अब वो सब जरूरी नहीं है. सो बिकॉज दैट इज इंपॉर्टेंट फ्रॉम इंटरव्यू पॉइंट ऑफ व्यू, बट ध्यान से सुनो. देखो सर, इसके बाद मजेदार क्वेश्चंस करूंगा. फर्स्ट ब्यूटीफुल थ्योरी, फटाफट थ्योरी कंप्लीट करेंगे, देन एसोसिएटेड क्वेश्चंस, चैप्टर वाइज थ्योरी क्वेश्चंस, थ्योरी क्वेश्चंस, थ्योरी क्वेश्चंस कर लेंगे. ओके, चलो. नाउ आई से द स्ट्रेस इज 50. You said, look at carefully. Can you tell me what is a vector quantity? पहले आप बताओ, मैं आपसे पूछूंगा सर, what is a vector quantity? Anyone? What is a vector quantity? बोलो फटाफट, कमेंट्स में बोलो सर, देखना है. फटाफट बताओ, कमेंट्स में बताओ, what is a vector quantity? Vector quantity कोई नहीं दे रहे सर, कमेंट्स नहीं कर रहे. डायरेक्शन मैग्नीट्यूड, डायरेक्शन मैग्नीट्यूड, डायरेक्शन मैग्नीट्यूड, डायरेक्शन मैग्नीट्यूड. सर 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 मुश्किल होगा. करंट हैज डायरेक्शन, करंट हैज मैग्नीट्यूड, बट इट इज नॉट अ वेक्टर क्वांटिटी. मैं हिंट दे रहा हूं सर, आई एम गिविंग यू हिंट. करंट हैज डायरेक्शन, करंट हैज मैग्नीट्यूड, बट इट इज नॉट अ वेक्टर क्वांटिटी. और बताओ, और कुछ? कीर्ति, कीर्ति, वाह. वैभव पटेल, पाटिल, वाह. प्लीज लुक एट मियर सेटिस्फैक्शन ऑफ, अगर कोई फिजिकल क्वांटिटी मैग्नीट्यूड डायरेक्शन को सेटिस्फाई कर रहा है, वो वेक्टर होना जरूरी नहीं है. इफ अ पर्टिकुलर क्वांटिटी सेटिस्फाइज हैज द मैग्नीट्यूड एंड डायरेक्शन, इट मे बी अ वेक्टर, इट नीड नॉट बी अ वेक्टर. So same is the case with stress. Though it has magnitude and direction, it does not satisfy laws of vector. What are the laws of vectors? Triangle law of vector, parallelogram law of vectors, polygon law of vectors. It will not satisfy. So please note down that pressure is a scalar quantity, but stress is a tensor of second order. What do you mean by tensor of second order? मैं beautifully बताया सर. अगर आप सिर्फ मैग्नीट्यूड डायरेक्शन देंगे, इट्स नॉट सफिशिएंट सर. फॉर एग्जाम्पल, मैं आपको एक गोल्डन पॉइंट बताता हूं. व्हाई इट इज नॉट सफिशिएंट? आई सेड, लुक एट केयरफुली, प्लीज लिसन केयरफुली. आई सेड, बहुत केयरफुली देखना सर, ये सब मैं क्लास में बहुत ब्यूटीफुली पढ़ाया था. देखो, आई सेड द स्ट्रेस इज, नॉर्मल स्ट्रेस इज, नॉर्मल टेंसाइल भी बोल दिया मैं, नॉर्मल टेंसाइल स्ट्रेस इज 50 मेगापास्कल. Is it sufficient, sir? Is it sufficient, sir? The normal stress is नहीं सर. क्यों? क्योंकि किस प्लेन के लिए, किस प्लेन का नॉर्मल है वो, ये तो बताया नहीं. फॉर एग्जाम्पल, ये एक प्लेन है. अब देखो, 50 मेगापास्कल टेंसाइल बोला. अब ये प्लेन पे टेंसाइल है या ए प्लेन पे टेंसाइल है? लिसन सर, लिसन केयरफुली. तो इसके लिए टेंसाइल है या फिर इसके लिए परपेंडिकुलर, वी डोंट नो. सो देयर इज अ नीड फॉर अस टू स्पेसिफाई द डायरेक्शन, द प्लेन ऑन विच इट इज एक्टिंग. दैट्स व्हाई इट इज टेंसर ऑफ सेकंड ऑर्डर. व्हाट डू यू मीन बाय सेकंड ऑर्डर? सो मैग्नीट्यूड तो चाहिए ही चाहिए, बिकॉज स्केलर को भी मैग्नीट्यूड चाहिए. स्केलर का मास जस्ट इनफ, मैग्नीट्यूड, ओके. बट यहां पे यू नीड डायरेक्शन. इज इट perpendicular to the plane or in the plane? Is it perpendicular to the plane or in the plane? Direction तो चाहिए. Apart from direction, you need plane. You have to specify the plane on which it is acting. So magnitude के साथ साथ दो चाहिए. ये और ये, दैट्स व्हाई इट इज टेंसर ऑफ सेकंड ऑर्डर, दैट्स व्हाई इट इज अ टेंसर ऑफ सेकंड ऑर्डर। अब देखो सर, आराम से देखो, और एक स्पेशल पॉइंट बताता हूं आपको। लेट अस टेक अ स्पेशल पॉइंट, देखो देखो आराम से। फॉर एग्जाम्पल आई टेक अ स्पेशल केस ऑफ दिस ना, और एक बात है सर, फर्स्ट लेट अस टेक द स्पेशल केस ऑफ नॉर्मल स्ट्रेन। ओह, बोलो एक बार, ओह, स्पेशल केस ऑफ नॉर्मल स्ट्रेन। सब लोग जिंदा है? सब लोग जिंदा है रे? यस, जिंदा है। ओह, देखो एक बार, स्पेशल केस ऑफ नॉर्मल स्ट्रेन। माय डियर स्टूडेंट्स, let us take this as origin, and there is a line. There is a line. All distances are measured from this. Now there is a line. For example, this is the member and loaded like this. मान लो इसको हम लोड ऐसा डालें. This is the x direction. X is measured from here. बहुत carefully देखना सर. This is very important. And this year there can be a question on this. अब मुझे blame मत करना. This year the question can be on this. अब मुझे blame मत करना. इधर देखो. अब इधर देखो रे. ना देखो. Let me take this as point A and let this length be XA. Let me take this as point B and let this length be XB. Now I am interested in this member. I am interested in this length. Now you tell me what is the original length. Can I write this is before loading. माय डियर स्टूडेंट्स, अभी इसको लोड नहीं डाल, इस पे लोड नहीं डाले, इस मेंबर पे लोड नहीं डाले, ये एक ऐसा ही लाइन सेगमेंट है, इस पे लोड नहीं डाले। वेरी गुड। लेट दिस लेंथ बी XA, लेट दिस लेंथ बी XB। व्हाट इज द ओरिजिनल लेंथ? AB के बीच का लेंथ बताओ। ये XB है, ये XA है, दिस XB XA। तो AB का लेंथ कितना है सर? दिस इज ओरिजिनल लेंथ, मतलब लोड डालने से पहले। सो इट इज XB माइनस XA। दिस इज द ओरिजिनल लेंथ, XB minus XA. Let me write it as DX. चलो कोई बात नहीं, change in this length. Is it okay? Wonderful sir, wonderful. अब देखो, now let me apply load. अब लोड अप्लाई करो। लोड अप्लाई करने के बाद आफ्टर अप्लाइंग लोड, डियर स्टूडेंट्स, मान लो ये पॉइंट यहां आ गया, ये पॉइंट यहां आ गया, मतलब कितना शिफ्ट हुआ? पॉइंट ए कितना शिफ्ट हुआ? लेट मी राइट इट एज यूए। प्लीज नोट डाउन दैट यू का मतलब डिस्प्लेसमेंट ऑफ पॉइंट ए। पॉइंट ए इधर से इधर डिस्प्लेस हुआ, तो यूए इज डिस्प्लेसमेंट ऑफ पॉइंट ए। एक्स डायरेक्शन में जो भी डिस्प्लेस हुआ मैं उसको यू करूंगा, वाई डायरेक्शन में जो भी डिस्प्लेस हुआ उसको वी करूंगा। अब देखो, नाउ आफ्टर द एप्लीकेशन ऑफ लोड, लेट दिस पॉइंट मूव टू दिस पोजिशन। मान लो लेट दिस बी सम यूबी। यू टेल मी व्हाट आर यूए एंड यूबी। दिख रहा है सर? यूए यूबी दिख रहा है। वेरी गुड। ए इधर शिफ्ट हुआ, बी इधर शिफ्ट हुआ। ओके, अब आप बताओ, सब डिस्टेंसेस ऑरिजिन से। अब फाइनली कैन आई से माय ए वाज हियर, नाउ इट इज हियर। माय बी इट वाज ओरिजिनल हियर, नाउ इट इज हियर। कैन आई कॉल दिस एज द फाइनल लेंथ? कैन आई कॉल दिस एज फाइनल लेंथ माय डियर स्टूडेंट्स? क्या मैं इसको फाइनल लेंथ बोल सकता हूं? डेफिनेटली इसको फाइनल लेंथ बोल सकता हूं सर। आज कुछ तगड़े 15 क्वेश्चंस करने वाले हैं। थ्योरी कंप्लीट करने के बाद नए 15 क्वेश्चंस वी आर डूइंग। लेट मी कंप्लीट थ्योरी फर्स्ट। आर यू रेडी? एंड सब लोग कैलकुलेटर लेके रेडी बैठना। Okay, leave it. Now you tell me what is this final length. पहले आप XB को कैलकुलेट करो। What is this? Can I write this as XB plus UB? इधर देखो रे, B का कोऑर्डिनेट कितना है रे? XB इधर आ गया, सॉरी एक सेकंड, अब B किधर आ गया सर? देखो B पॉइंट इधर आ गया, सो देयरफॉर दिस इज XB plus UB। अब A किधर आ गया? A इधर आ गया, देखो A इधर आ गया, तो XA plus UA। अरे यार ओरिजिनली यहां पे था, अब यहां आ गया, सो XA plus UA, दिस इज XA plus UA। नाउ यू टेल मी व्हाट इज द फाइनल लेंथ। अगर आपको ये फाइनल लेंथ चाहिए, इफ यू वांट दिस फाइनल लेंथ, दिस लेंथ minus this length, that is XB plus UB minus XA. So therefore the final length is XB plus UB minus XA plus UA. So now you tell me what is the final length. So it is XB minus XA plus XB minus XA plus UB minus UA. So therefore the final length is, मैं थोड़ा फास्ट जा रहा हूं because it is not a regular class. Regular class तो मैं 100 hours में पढ़ा है SOM, तो ये स्लोली नहीं जा सकते because it is examination time. It is only revision class. Is it okay? Right. Now can we write this as, what is this XB minus XA? XB minus XA is original length plus इसको लिखेंगे UB minus UA को, let me write it as DU. UB minus UA को DU लिखेंगे। Exactly. Now आप बताइए what is strain? Dear students, what is the strain? Strain is nothing but, one second please. 1 second please. Strain is nothing but, white ले लेंगे. Strain is not, अरे कहाँ गया रे ये, कहाँ गया रे? Strain is nothing but change in length by original length. I'm talking about engineering strain. अभी true strain नहीं है. So what is the change in length? Therefore, it is final length minus original length by original length. Final length. So let me calculate. So what is final minus original? You bring LO to this side. LO. तो LF minus LO क्या हुआ? DU हुआ. LF minus LO. LF minus LO. अरे यार इसको इधर लाना. LF minus LO is DU by LO. What is LO? DX. So please note on that the strain in X direction is given by, my dear students, एक second. The strain in X direction, एक second. The strain in X direction is given by du by dx. Similarly, अगर आपको what is U? Displacement in X direction. अगर आपको strain in Y direction चाहिए, it will be dV by dy. Wonderful, my dear students. Similarly, अगर आपको Z direction में चाहिए, U, V, W and X, Y, Z. So these are normal strains. There can be a question this year. देखो, लेकिन X direction, Y direction, Z direction are independent direction. So इसको हम ऐसे भी लिख सकते हैं del U by del X. इसको हम del V by del Y. इसको हम del W by del Z. This is the normal strain in Z direction. This is the normal strain in X direction, Y direction. This is the normal strain in X direction. ये बहुत इंपॉर्टेंट है. क्या पता कल देखो एग्जाम में the displacement in X direction is given by X square Y plus X cube and Y में कुछ देगा. So what is the strain in X direction? Please know at some point he'll give you. At some point 1,3. So कुछ नहीं, dou U by dou X कर देना. Strain in X direction चाहिए. Dou U by dou X करना. तो और you get some value and put this wherever you want, you can get the normal strain. तो कर सकते सर आप? Can you do this? Dear students, can you do this? Can you do this? अरे यार क्या हो रहा रे? क्या लेके आयो जग में, क्या लेके जाएगा वो बंधु? क्या हो रहा है? क्लियर क्लियर? कृष्ण तेजा. वंडरफुल. चलो आगे बढ़ते हैं. नाउ देखो, लेट्स गो टू shear strain. I will designate shear strain with gamma. I will designate shear strain with gamma. Very good. अब देखो, the change in the angle originally perpendicular. For example, shear strain को measure करना है. So for example, this is the original shape. This is the original shape. This is the original shape. Now please observe these two under consideration. ये देखो, ये line और ये line. What is the angle, sirs? What is the angle? 90 degree original. So after the application of white ले लेंगे. After the application of shear load, let it deform, my dear students. मान लो ये इधर आ गया, ये इधर आ गया. अब क्या एंगल बन गया? Now this is the new angle. Alpha is the new angle. And what was the original angle? The original angle is 90 degree. मतलब ये दोनों लाइंस के बीच में original angle is this, original angle is this 90. What is the new angle? New angle is alpha. That change, originally it was 90, now it is this angle. The change in the angle with respect to the original perpendicular line segments. This is shear strain. Now अब देखो सर, मुझे ये चाहिए, ये एंगल चाहिए, ये चाहिए. दिस इज गामा shear strain. So very simple here. यहाँ पे gamma is equal to anyone. Original is 90 and the new is alpha and this is my shear strain. In this case, what is alpha? Alpha is less than 90 and the convention is such a shear strain is taken as positive. तो ये मत बोलना सर क्या हमेशा पॉजिटिव लेते हैं. फॉर एग्जाम्पल let me explain. I will tell you one important point. So ये original 90. Afterwards, let us say this line, afterwards this line has deformed something like this. Now this is the final angle. Let us say, what is the change in angle? Originally it is 90. Now it is alpha. What is the change? It is this. And alpha is greater than 90. So therefore this is negative. So whenever the final angle is more than 90, such a shear strain we take it as negative. Whenever the final angle is less than 90, such a shear strain we take it as positive. Now there was a question in GATE examination. He has not mentioned any convention. बहुत ध्यान से सुनना sir. He has not mentioned any convention. And initially, when the key was released, he took this convention. What is that convention? So when final angle is, he said, और एक बात है sir, this shear strain is measured in radian. I repeat, shear strain is measured in radian. अब देखो क्या कैसा? The original angle is 90. Let the final angle is 89. 89. Let us say the final angle. What is the shear strain? What is the shear strain? Yes, कुछ नहीं है. 90 minus 89, it is 1 degree. But don't put it as 1 degree. You put it in radian. 180 degrees correspond to pi radian. So 1 degree is how many? So therefore 1 degree का मतलब pi by 180 radian. That's it, sirs. So there was a question, sirs. ऐसे ही question था. And there are two options. One was positive, pi by 180, and the other option was minus. Some students gave pi by 180, others gave minus pi by 180, something like this. And he has not mentioned any convention. When the key was released, so he gave positive answer. But some people challenged it because convention was not given. That is your convention. That's why finally he gave both answers correct. The final key release हुआ, दोनों भी correct. So you don't have to worry. You don't have to worry. Is it clear, my dear students? Is it clear? मैं आगे बढ़ सकता हूं, sir? Wonderful, sir. और एक बात, यहां तक किसी को कोई प्रॉब्लम नहीं ना, आप रेडियन में पुट करना. ओके, कोई बात नहीं सर. अब देखो, नाउ shear strain in XY plane. फॉर एग्जाम्पल ये ओरिजिनल है. अब देखो, व्हाट इज द ओरिजिनल एंगल? ओरिजिनल इज दिस. मान लो आफ्टरवर्ड्स, प्लीज लिसन केयरफुली, आफ्टरवर्ड्स लेट अस assume that this line has become something like this, and this line ये वाला ऐसा हुआ, and finally this is the shape after loading. Now you tell me, originally it was 90, now this is the angle. Dear students, ये angle है alpha. So let this angle be theta 1, let this angle be theta 2. Sir, ये question मैं expect कर रहा हूं इस साल के लिए. I'm expecting this question for this year. ये मत बोलना अगर नहीं आया तो सर आपने एक्सपेक्ट किया नहीं आया. Expectation is only expectation. मैं एक्सपेक्ट कर रहा हूं सर. Now let's find out what is the shear strain in this case. तो originally what was the angle? एक बार देखना, ये original है 90 and finally ये ऐसा है. देखो, finally because of loading the shape has become like this. So let this be theta 1, let this be theta 2. देखो, originally 90, अब alpha हो गया. What is the shear strain? It is original angle से final angle subtract कर लेना. Original this line and this line. अब ये line इधर आ गया, अब ये line इधर आ गया. So what is the final included angle? Alpha. So original minus alpha ये आ गया. ये shear strain है. कैसे करे सर? कुछ नहीं है सर. My dear students, can I say that अगर ये line draw करो तो can I say that, देखो आराम से देखो this कहां गया रे? हाँ, this plus this theta 1 plus alpha plus theta 2, can I write it as 90? Theta 1 plus alpha, yes, it is 90, but I want 90 minus alpha. So shear strain in XY plane 90 minus alpha. तो 90 minus alpha कितना होगा? अल्फा को इधर लेना, theta 1 plus theta 2. जस्ट कैलकुलेट theta 1 plus theta 2. अब देखो x डिस्प्लेसमेंट, ये कितना डिस्प्लेस हुआ? यहां पे था, फाइनल ये हुआ. दिस इज द x डिस्प्लेसमेंट, आई रेट इट एज du. एंड दिस इज, इट वाज हियर, नाउ इट इज हियर. ये कौन सा? ये लाइन इधर था, अब इधर आ गया. तो यहां से यहां डिस्प्लेस हुआ. व्हाट इज दिस? आई विल कॉल इट एज y डिस्प्लेसमेंट इज dv, एंड लेट दिस बी dx एंड लेट दिस बी dy. कैन आई कैलकुलेट tan theta 1? देखो एक बार, tan theta 1 इज इक्वल टू, अरे यार एक सेकंड प्लीज, 1 सेकंड, कहां हुआ, क्या हुआ पता नहीं, सडनली गुम हो गया इसको. एक सेकंड प्लीज, होता है. एक मिनट दीजिए, थोड़ा सब्र करो, रुको जरा. तो इन द मीन टाइम, वाई टू वेस्ट अवर टाइम? इन द मीन टाइम आगे देखो, भगवान अपने साथ है, भगवान साथ है तो कुछ भी कर सकते हमारे ऊपर वाला. अब देखो, अभी फिर होगा, कोई चिंता मत करो, तब तक मैं थ्योरी कर लूंगा, कोई टेंशन नहीं, थोड़ा थ्योरी. So कुछ नहीं, you find out theta 1 and theta 2. So what is theta 1 and theta 2? Tan theta 1, tan theta 2. And देखो my dear students, नो, एक सेकंड प्लीज। आई एम नॉट यूजिंग रेगुलरली, दैट्स व्हाई दिस प्रॉब्लम इज कमिंग। अब कोई टेंशन नहीं है ना सर? कोई टेंशन नहीं है ना सर? अब देखो, अरे अरे इसको भी क्या हुआ? इसको बोलते हैं काला जादू, ब्लैक मैजिक। वन सेकंड प्लीज। कौन कर रहा है काला जादू? बोलो एक बार। पुष्पेंद्र दुबे कर रहा है? चलो कोई बात नहीं, देखो आ गया, होता है। प्लीज थोड़ा पेशेंस रखो सर। नाउ व्हाट इज tan थीटा 1? tan थीटा इज ऑपोजिट बाय एडजेसेंट, तो कैन आई राइट दिस एज du by dy? du by dy, yes. And what is tan theta 2? एक बार देखना, tan theta 2 dv by dx, एग्जैक्टली dv by dx। ऐसा क्यों हो रहा रे? ऐसा क्यों हो रहा रे? थोड़ा पेशेंस रखो रे, थोड़ा पेशेंस रखो, थोड़ा पेशेंस रखो। हो रहा है, हो रहा है, कोई कर रहा है, कर रहा है कुछ, कोई बात नहीं, थोड़ा पेशेंस रखो प्लीज। हैव पेशेंस फॉर सम टाइम। हाँ, so I can calculate tan theta 1 as du by dy, and tan theta 2 as dv by dx. So if you want shear strain, that is 90 minus alpha, which is nothing but theta 1 plus theta 2. Already I know theta 1, already I know theta 2. I can calculate theta 1 plus theta 2. I'll get the shear strain in xy plane. So यहाँ पे one point I want to highlight. What is that point? इसको क्या हुआ रे? वन सेकंड प्लीज। हाँ, देखो, व्हाट आई वाज ट्राइंग टू टेल इज, क्या हो रहा है इसको, पता नहीं। And you know, actually the deformations are very very small. I repeat, says the deformations are very very small. Therefore, tan theta, whenever the angle is very small, tan theta will be theta only. So therefore, tan theta 1 will become theta 1. Tan theta 2 will become theta 2. So therefore, theta 1 plus theta 2 I can easily calculate. There is no problem. So you can, और एक बात बता रहा हूं sir, the displacements in x and y directions will be given. So just calculate dou u by dou x. Just calculate dou v by dou u by dou y. Be careful, be careful. नॉर्मल के लिए x एंड u आर इन द सेम डायरेक्शन, बट शेयर स्ट्रेन के लिए ऑपोजिट है। देखो, लेट मी एक्सप्लेन सर, लेट मी एक्सप्लेन। ये हो जाने दो, एक बार सही हो जाने दो सर। वायर कनेक्शन का प्रॉब्लम है, अभी तक तो सही था रे। एक सेकंड, डोंट वरी। मैं इसका इलाज करूंगा। या देखते हैं, बिकॉज आई हैव कलेक्टेड सम वेरी गुड क्वेश्चंस। आ रहा हूं सर, आ रहा हूं। ऐसा करेंगे, कल दूसरे स्टूडियो पे जाएंगे। नहीं, अभी अभी मत जाना, डोंट गो एनीवेयर, अभी मत जाना सर, मेरे दूसरे स्टूडियो पे जाएंगे, अभी नहीं, कल देखते हैं। तो सता रहा है यार। ऐसा करूंगा इसको, नहीं वेट करो, वेट करो, हो जाएगा, वेट करो जस्ट। नहीं 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 नहीं, एक सेकंड। देखते हैं सर। हाँ, in the meantime I'll explain some theory. In the meantime, I'll explain without wasting time. I'll explain theory. So we have calculated. अब आ रहा है शायद, अब आ रहा है रे, अब आ रहा है रे, आ रहा है, कोई दिक्कत नहीं। सो ओके, यस यस, आएगा आएगा, आ रहा है, कोई दिक्कत नहीं। हाँ, तो वी हैव सीन शेयर स्ट्रेन, उसका भी इक्वेशन है। अब थोड़ा टेंसाइल टेस्ट पे आएंगे, यूटीएम पे आएंगे, कर देंगे सर, कर देंगे, विदाउट वेस्टिंग टाइम कर देंगे, कर देंगे। आ रहा है, तब तक मैं पानी पी लेता हूं, 1 मिनट का ब्रेक लीजिए आप। यस, आएगा आएगा रे आएगा, आएगा रे आएगा। कहां गया हम रिवीजन 1? यस, इंसर्ट्स, आएगा, हो गया। दिख रहा है सर, कोई दिक्कत नहीं है ना? दिख रहा है ना? अब मैं थ्योरी पढ़ाते पढ़ाते, सो एक काम करेंगे, शैल आई डू वन थिंग, while explaining theory I'll do questions, will it be fine? Will it be fine? While explaining questions I'll do theory, is it okay? You are not saying anything. आप तो कुछ बोलो रे, is it okay? Will it be fine? अब सही होगा सर, ओके, चलो देखते हैं सर। प्लीज आराम से, एवरीवन प्लीज कीप कैलकुलेटर्स रेडी, एवरीवन कीप कैलकुलेटर्स रेडी। व्हाइल एक्सप्लेनिंग थ्योरी आई विल डू क्वेश्चंस, तो पूरा रिवाइज हो जाएगा। इज इट ओके? अब देखो, आराम से आराम से। या अब देखो, प्लीज लिसन माय डियर स्टूडेंट्स, यू नो, हाँ एक बार हम, विल इट बी फाइन? विल इट बी फाइन? व्हाइल एक्सप्लेनिंग थ्योरी आई विल टेक क्वेश्चंस। कहां कहां थ्योरी चाहिए, आप यस बोलेंगे तो मैं आगे बढ़ूंगा, ओके है? ओके, अब अच्छे क्वेश्चंस आइए, देखो, आई थिंक यू कैन एंजॉय नाउ। देखो, अरे अल्लाह, इसको क्या ब्लैक मैजिक किया रे, कौन कर रहा है ये ब्लैक मैजिक? हाँ, मैं बताऊंगा। अरे अरे अरे, वो देखो, अरे देखो, कल मैं दूसरे इस पे जाऊंगा सर, आई विल गो टू माय न्यू अनदर स्टूडियो। हाँ, आई विल गो टू माय न्यू स्टूडियो। क्या बोला है ये? हाँ, ए मेटेलिक प्लेट इज इन अ स्टेट ऑफ प्लेन स्ट्रेन। आपको पता है सर व्हाट इज अ प्लेन स्ट्रेन कंडीशन? आपको पता है व्हाट इज अ, 2 मिनट के लिए कूल होने दीजिए। अरे कहां कूल हुआ, ये तो कूल ही है, तब से ठंडा ठंडा कूल है, कोई बात नहीं। देखो, यू नो माय डियर स्टूडेंट्स, प्लेन स्ट्रेन का मतलब स्ट्रेन इन वन ऑफ द प्रिंसिपल डायरेक्शंस इज 0। मे बी सिग्मा एक्स, मे बी एप्सिलॉन एक्स, मे बी एप्सिलॉन वाई और एप्सिलॉन जेड। तो यहां पे प्लेन स्ट्रेन बोला है, देखो क्वेश्चन को ध्यान से सुनो, प्लेन स्ट्रेन बोला है, देखो अच्छा क्वेश्चन है सर, प्लेन स्ट्रेन कंडीशन, तो क्या दिया है सर, एप्सिलॉन जेड इज इक्वल टू 0 विथ यहां पे सिग्मा एक्स इज इक्वल टू सिग्मा वाई। अरे यार ही से सिग्मा एक्स एक्स, इसका मतलब सिग्मा एक्स, सिग्मा वाई वाई का मतलब सिग्मा वाई ओनली। ओके, दे आर इक्वल एंड दे आर नॉट जीरो, मतलब दोनों इक्वल है लेकिन वो जीरो नहीं है, दोनों इक्वल है लेकिन वो जीरो नहीं है। इफ द पॉइजन्स रेशियो इज 0.3, कैन यू टेल मी व्हाट इज द मीनिंग ऑफ पॉइजन्स रेशियो? फॉर अ homogeneous isotropic material, the ratio of transverse strain to the longitudinal strain. तो अगर आप मटेरियल को फॉर एग्जांपल एक्स डायरेक्शन में लोड डाल रहे हैं, डेफिनेटली देयर विल बी स्ट्रेन इन एक्स डायरेक्शन, बट इट इज ऑल्सो ऑब्जर्व दैट देयर इज अ स्ट्रेन इन अदर डायरेक्शंस ऑल्सो. Even though I have not loaded in this, it is free to contract. For example, if I pull it, it is contracting. It is contracting. मतलब there is a strain in y direction also. So that y direction strain by x direction strain, you call it as Poisson's ratio. It is observed that for a homogeneous isotropic material within elastic limit, the strains are same in other two directions. For example, x डायरेक्शन में लोड डाल रहे हैं तो y डायरेक्शन में और z डायरेक्शन में स्ट्रेन यूनिएक्सियल लोडिंग डाल रहे हैं तो y डायरेक्शन और x डायरेक्शन z डायरेक्शन में स्ट्रेन सेम है. दैट strain in lateral strain to the longitudinal strain, you call it as Poisson's ratio. अब देखो सर, ये क्वेश्चन देखो क्या बोला है सर, what is the Poisson's ratio is 0.3, what is sigma z by, अच्छा क्वेश्चन है सर, sigma z by sigma x कितना है पूछ रहा है. कैसे करेंगे सर इसको, कैसे करेंगे सर, what a beautiful question. इधर देखो, you know that the strain in z direction is given by, कुछ याद है सर, sigma z by e minus nu by e into sigma x plus sigma y. Is it correct? किसी को याद है ये इक्वेशन? Is it clear sir? Is it clear my dear students? Is it clear? किसी को याद है? Very good पुष्पेंद्र जुबी, वाह. So already he has given plane strain. तो epsilon z क्या है? Epsilon z 0 दिया है, 0 दिया है, ये 0 दिया है, 0. So sigma z by e minus nu by e into sigma x plus sigma y. तो देखो सर क्या होगा, अब देखो ध्यान से सुनो, आराम से करेंगे सर. दिस इज गिवन, तो कैन आई राइट दिस एज सिग्मा z by e is equal to nu by e. आई एम टेकिंग दिस टू दिस साइड, तो सिग्मा x प्लस सिग्मा y. वेरी गुड, तो ये कट गया, तो सिग्मा z इज इक्वल टू न्यू इंटू सिग्मा x प्लस सिग्मा y. अब क्या पूछा है सर, ही इज आस्किंग सिग्मा z बाई सिग्मा x, तो सिग्मा z बाई सिग्मा x, तो इसको सिग्मा x से डिवाइड करना, तो क्या करेंगे, दोनों साइड सिग्मा x से डिवाइड करना, न्यू इंटू सिग्मा x प्लस सिग्मा y बाई सिग्मा x से डिवाइड करना, तो ये वैल्यू चाहिए. सो यू डिवाइड विद सिग्मा x, यू डिवाइड विद सिग्मा x. अब सुनो केयरफुली, ऑलरेडी सिग्मा x सिग्मा y सेम दिया है प्रॉब्लम में, सिग्मा x सिग्मा y इज सेम, तो कैन आई राइट दिस एज सिग्मा y एज सिग्मा x. सो देयरफॉर सिग्मा z बाई सिग्मा x इज इक्वल टू न्यू इंटू सिग्मा y को भी सिग्मा x दिया है, सो दिस सिग्मा y कैन बी रिटन एज सिग्मा x, तो सिग्मा x प्लस सिग्मा x इज 2 सिग्मा x बाई सिग्मा x, तो ये कट गया. सो देयरफॉर सिग्मा z बाई सिग्मा x इज इक्वल टू 2 times Poisson's ratio, 2 times, but the Poisson's ratio is given as 0.3, so therefore this is equal to 0.6. So the answer is 0.6. Is it clear my dear students? Dear students, is it clear? Final answer is 0.6. Anil Verma, you are wrong. Anil Verma, you are wrong. Anyone got 0.6? Anyone got 0.6? Very good. Next question. ये ले लो, अब मैं बताता हूं, सुनो सर प्लीज, सम गुड क्वेश्चंस विद थ्योरी. देखो, अब देखो, इज इट ओके? इससे पहले ये क्वेश्चन करेंगे सर, ये सेकंड का अभी ले लूंगा, ये करो, पढ़ो एक बार, प्लीज रीड द क्वेश्चन, प्लीज रीड द क्वेश्चन, प्लीज रीड द क्वेश्चन, प्लीज रीड दिस क्वेश्चन. What a beautiful question this is. A material made up of alternating layers of metals A and B This is metal A, dear students. This is metal A and this is B. B. If the volume percentage of B is 25, the elastic modulus of this member is. अच्छा क्वेश्चन है सर, अच्छा क्वेश्चन है सर, प्लीज लुक एट. तो स्क्रीन पे सब क्लियर दिख रहा है सर? कैन यू सी एवरीथिंग इन अ क्लियर मैनर? स्क्रीन पे सब क्लियर दिख रहा है? इधर देखो. A material made up of alternating layers of metals A and B is loaded as shown below. If the volume percentage of B is 25, मतलब B का परसेंटेज कितना है? मतलब एक्चुअली A और B का कॉम्बिनेशन का मटेरियल बनाए हम. We have made a material of a combination of A and B. Is it okay? Is it okay? अब क्या बोल रहा है सर? What is the elastic modulus of this? देखो एक बार. What a beautiful question this is, sir. The elastic modulus of A is given. देखो ये A है. अरे यार ये कलर चेंज करेंगे सर, ये कलर चेंज करेंगे. इधर देखो, मैं ऐसा करूंगा सर आपको समझाने के लिए. ये एक अलग मटेरियल है B. लाल वाले को B ले लेंगे. ये लाल वाला B है, लाल वाला B है. गुड क्वेश्चन सर. लाल वाला B है. This red one is B. And what is the percentage of volume of B? What is the percentage of volume of B? What is the percentage of volume of B? B का volume है 25%. So if B is 25%, what is the volume of A? If B is 25%, what is the volume of A? 75%. नहीं आ रहा सर, नहीं आ रहा है सर, नहीं आ रहा है सर. कितना प्यारा सा क्वेश्चन है सर. आप बोलो एक बार, ये क्वेश्चन अच्छा लगा या नहीं? एक बार देखो. 75, वेरी गुड. अच्छा लगा या नहीं? क्वेश्चन को पढ़ो रे, क्वेश्चन को पढ़ो रे. यस, अब देखना, बहुत सिंपल से देखो. यू नो माय डियर स्टूडेंट्स, व्हाट आई डू इज, एक काम करते हैं सर. व्हाट आई डू इज, डियर स्टूडेंट्स, एक काम करते हैं. इधर देखो, यंग्स मॉड्यूलस ऑफ ए कितना दिया? दिस इज अ ब्यूटीफुल क्वेश्चन. इसको इक्विवेलेंट में कन्वर्ट करेंगे. इधर देखो, विल कन्वर्ट दिस इनटू इक्विवेलेंट. इसका इक्विवेलेंट सेम लोड होगा. ओके, व्हेन कैन आई कॉल बोथ एज इक्विवेलेंट? आप बताइए, व्हेन कैन आई कॉल बोथ एज इक्विवेलेंट? अंडर द सेम लोड, same elongation. So whatever this member is elongating, this should also elongate by the same amount. And you have studied that within elastic limit, the elongation is given by under axial loading. Is it correct, sir? Under axial loading, the elongation is given by PL by AE. लेकिन इसको अप्लाई करने के लिए क्या कंडीशंस है, मैं क्लास में बताया था. The member should be prismatic. Everywhere the cross section is same. इधर देखो, एक बार देखो सर, आप देखो. If you see the cross section, everywhere it is same, everywhere it is same, everywhere it is same. Yes or no? Everywhere. So whether it is this cross section or this cross section, everywhere it is uniform. अब कैसे करें सर? कोई आंसर दे दो, देखते हैं सर. I'll be very happy अगर कोई आंसर दिए तो. I'll be very very happy waiting for your answers. वाह, अब मैं बताता हूं सर, मैं इसका राज बताता हूं. डियर स्टूडेंट्स, यंग्स मॉड्यूलस ऑफ दिया, देखो देखो, ए का मॉड्यूलस कितना दिया? 200. बी का कितना दिया? 100. मैं अब बहुत अच्छी तरीके से पढ़ाऊंगा सर इसको. देखो, ए का मॉड्यूलस कितना दिया? 200. बी का कितना है? 100. इधर देखो, आई विल टेक अ न्यू स्लाइड एंड आई डू दिस क्वेश्चन. देखो, दिस इज द मेंबर. यहां पे yes, let this be the total length. इसका equivalent ये है, this is the equivalent, and this is A. Don't worry, don't worry, don't worry. Anyone got the answer? Waiting for answers. लेकिन कोई भी आंसर नहीं दिया सर, कोई भी आंसर नहीं दे रहे सर, बहुत गलत बात है. द यंग्स मॉड्यूलस ऑफ दिस लाल वाला इज B. दिस इज B. the Young's modulus of B is given as 100 and the Young's modulus of A is given as 200. Correct na? 21.030 gigapascal. 30 नहीं waiting for your answers इधर अब मैं बताता हूं सर. Under the action of load, अगर ये लेंथ L है तो L है. अब देखो सर, he has given that volume is equal to area into length. अगर आप for example whether you are taking A or B, is there any change in the area sir? आप देखना, whether you take A or B, is there any change in area? ऐसा देखो, ऐसे रख दिए, इसका एरिया ये है, बी का ये है, ऐसा रख दिए. मैं आपको बता रहा हूं, इधर देखो सर, प्लीज सुनो केयरफुली. इधर देखो, आई एम कीपिंग लाइक दिस, प्लीज आई एम कीपिंग लाइक दिस. इधर देखो, कीपिंग लाइक दिस. देखो क्या इसका एरिया और इसका एरिया चेंज हो रहा है? नहीं ना. बोथ हैव से, वाह समवन गिव 160, वाह समवन गिव 160, वाह. देखो क्या एरिया चेंज हो रहा? नहीं. अरे यार दोनों ऐसा रख दिए, तो इज देयर एनी चेंज इन एरिया? नो. तो किस में चेंज आ रहा है? सो आई कैन से दैट एरिया इज नॉट चेंजिंग. तो वॉल्यूम डिपेंड्स ऑन व्हाट? लेंथ. इसका मतलब है दिस लेंथ, दिस लेंथ, दिस लेंथ. तो ये लेंथ कितना है सर? 25%. तो आउट ऑफ द टोटल लेंथ L, 25% लेंथ इज ऑफ B एंड 75% लेंथ इज ऑफ A. नहीं आया सर? किसी को समझ में आया? नहीं आया? ध्यान से सुनो सर. इज देयर एनी चेंज इन द एरिया? इट्स लाइक दिस सर. एक ऐसा है, इधर देखो सर, एक ऐसा है और दूसरा ऐसा है, एक ऐसा है. तो ये जो एरिया है सेम है. द ओनली चेंज इज व्हाट? दिस लेंथ, दिस लेंथ. सो प्लीज ऑब्जर्व, वॉल्यूम इज एरिया इंटू लेंथ. एरिया इज नॉट चेंजिंग, तो वॉल्यूम डिपेंड्स ऑन लेंथ. So volume of B is 25%, means 25% length is occupied by B and 75% is occupied by L. अब very simple है सर. अब देखो, now, oh God, अब देखो, please listen carefully. So now I can write, my dear students, एक बार देखना, this is the one and this is your equivalent. तो different ये है. तो I will write under the action of load. देखो, DL change in length is PL by AE. तो यहां पे क्या होगा? लोड इज सेम, तो P, एरिया इज नॉट चेंजिंग, लोड इज सेम, P, एरिया इज नॉट चेंजिंग. फर्स्ट वाले का L बाई E. तो B का लेंथ कितना है? 0.25 L ऑफ द टोटल लेंथ L. 0.25 इज B एंड देखो P बाई A इज कॉमन, L बाई E. व्हाट इज द Young's modulus of B? 100 प्लस 75% is again PL by AE. P by A कॉमन लिया, L by E. फर्स्ट वाले B का L है 0.25, उसका E है 100 और A का लेंथ है 0.75 एंड उसका Young's modulus is 200 and that should be equal to PL, total length is L by area is not changing, E equivalent. Please tell me, is this equation clear? My dear students? Let me repeat, sir. So volume is 75%, 25% is said, but volume is area into length. Area is not changing. When area is same, my volume depends on what? Length. So B part length is 25%, A part length is 75%. A part is 75 of the total length, B is 25. So PL by AE, अरे यार PL by AE, load is same, area is same, तो P by A को common ले लेना. When I take P by A common, L by E will be left. L is, for B it is 0.25, for B it is 100, for A it is 0.75, for A it is 200. That should be equal to equivalent. P total length is L by area, तो same है area, E is equivalent. So P by A is gone, L common, take it out. So therefore 0.25 by 100 plus 0.75 by 200 is equal to L is gone. L को cancel कर दिए दोनों तरफ से, L कट कर दिए. So it is 1 by E equivalent. So this is 1 by 4, तो 400 plus 3 by 0.75 is 3 by 4. 3 by 4 का मतलब ये 800 is equal to 1 by E equivalent. So therefore multiply with 2, तो कितना होगा? 2 मतलब 800. 2 plus 5 by 800 is equal to 1 by E equivalent. So E equivalent will be equal to 800 by 5. So उल्टा करो, 800 by 5 will be equal to 160. Is it clear, sir? 160 is the right answer. Anyone got the answer? अच्छा क्वेश्चन था सर. Okay, sir, you are not saying anything. Is it okay? Is it okay? Now, अभी ये क्वेश्चन ले लेंगे. ये छूट गया था. We left one question. एक सेकंड, ये छूट गया था. अब देखो प्लीज, अच्छे क्वेश्चंस करेंगे सर. ओके, राइट 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 राइट. कंसिडर द फॉलोइंग स्ट्रेस स्टेट इंपोज्ड ऑन अ मटेरियल. दिस इज द स्ट्रेस मैट्रिक्स. तो कैसे रीड करेंगे सर स्ट्रेस मैट्रिक्स को? यहां पे सिग्मा एक्स होगा, यहां पे सिग्मा वाई होगा, यहां पे सिग्मा जेड होगा, यहां पे टाउ ऑल आर टाउ एक्स वाई, टाउ एक्स वाई, समझ गए ना? टाउ एक्स जेड, समझ गए ना रे? So these are all shear stresses. I am interested. अब देखो, is it clear? Dear students, is it clear? Dear students, is it clear? अब देखते हैं. अब ये बताओ, what is this? Dear students, what is this? Can I write it as sigma x? What is this? Sigma y. Can I write this as sigma z? Yes. अब क्या पूछा देखो. If the material responds elastically with a volumetric strain of, what is the volumetric strain? The volumetric strain is given by, अच्छा क्वेश्चन है सर. The volumetric strain is given by 3.5 into 10 power minus 4. Okay, no problem at all. एक सेकंड, इसको थोड़ा मैं स्लाइड ऐड करता हूं. स्लाइड ऐड करता हूं सर. कहाँ है वो? ये वाला ना, ये वाला इंसर्ट. यस, अब देखो, अब देखो. हाँ, यस. Look at now. The volumetric, अच्छा क्वेश्चन है सर. The volumetric strain is given by, yes, पेन ले लेंगे, 3.5 into 10 power minus 4. एक सेकंड. The volumetric strain is given by 3.5 into 10 power. What do we mean by volumetric strain, sirs? What do we mean by volumetric strain? Change in volume to the original volume. Okay, that is volumetric strain दिया है. अब देखो, what is the bulk modulus? Bulk modulus पूछा है. आप तो जानते हैं सर, bulk modulus is given by, I have given the physical meaning of bulk modulus. It represents or it gives the resistance to the volumetric changes. Dilation, we also call it as dilation. Is it okay? अब देखो, what is bulk modulus? It is nothing but average stress to the volumetric strain. And I have given you the physical meaning also of this in my regular class. Average stress to the volumetric strain. अब सुनो carefully. What do we mean by average stress? Bulk modulus represents the change in volume. आप बताइए सर, for change in volume, which stresses are responsible? Normal or shear? मैं क्वेश्चन पूछ रहा हूं सर. For change in volume, which stresses are responsible? Anyone in the class? Which stresses are responsible for change in volume? It is normal. So therefore, अगर normal responsible है, तो इसका कोई काम नहीं है सर. इसका कोई काम नहीं है. इसका कोई काम नहीं है. This is sigma x, sigma y, sigma z. So what is sigma average? Sigma average is sigma x plus sigma y plus sigma z by 3. I have explained all this in my regular classes. So therefore, sigma average is equal to 90 plus 20 plus 140 by 3. What is sigma average? So this is 90 minus 20 is 70. 70 plus 140 is 210. 210 by 3 is 70. So sigma average is 70. देखो यूनिट देखो. All these are in megapascal. So therefore, आपको ये वैल्यू मेगापास्कल में है, तो वॉल्यूमेट्रिक स्ट्रेन का कोई यूनिट नहीं है, तो K will be in megapascal. तो K is equal to sigma average is 70 megapascal. Already I have calculated. Volumetric strain is 3.5 into 10 power minus 4. So you will get this as how much, sir? इतना आ रहा है सर. बोलो एक बार. बोलो रे. How much is this? 20 into 10 power minus 4 megapascal, और करेक्ट ना? 10 power 4 ये ऊपर जाएगा. So 200 into 10 power 3 megapascal. Am I right? अरे 20 into 10 power 4 को 200 into 10 power 3. But what is 10 power 3 megapascal? Gigapascal. So the answer is 200 gigapascal. Anyone got this answer? 200 gigapascal. किसी को आंसर आया सर? किसी को आंसर आया 200 gigapascal? Wonderful students. ठीक चल रहा है सर? Should I continue? क्या मैं कंटिन्यू करूं सर? शुड आई कंटिन्यू सर? अच्छे अच्छे क्वेश्चंस आने वाले हैं। ग्रेट स्टूडेंट्स ऑफ इंडिया, वंडरफुल स्टूडेंट्स ऑफ इंडिया, ये तो अभी किए, ये करो सर, ये करो सर। प्लीज रीड द क्वेश्चन, प्लीज रीड द क्वेश्चन, करो सर, प्लीज रीड द क्वेश्चन, आराम से आराम से। A perfectly elastic plastic material, let me draw sirs, let me draw sirs, इधर देखो, perfectly elastic plastic material, this is strain and this is stress. This is perfectly elastic plastic, this is perfectly elastic plastic, has a yield stress of 450 megapascal. Dear students, the yield stress is given, ये वाला yield है, how much is that given? And that is given as 450 megapascal. And the material fractures at a strain of, strain बोला है देखो, material fractures at a strain of 0.45. This is the fracture point, let us say. What is the strain given? This strain is given as 0.45. Correct? दिख रहा है सर सब? So can you see? Yes, yes, yes. And the fracture, the ratio of resilience to the toughness of this material is, and the Young's modulus is given. अच्छा question है sir. कैसे करेंगे? He is asking the ratio of resilience to toughness. Wonderful. What is resilience? The ability of the material to absorb energy up to elastic limit. Up to elastic limit. इसका मतलब है, my dear students, ये वाला देखो एक बार. This is your, this area represents resilience. ये वाला एरिया resilience up to elastic limit, और ये फ्रैक्चर है. अब देखो एक बार, look at carefully. And up to fracture, calculate the area. And this area is nothing but your toughness. And this is nothing but your resilience. Actually, I should call it as modulus of resilience. Whenever you divide with volume, it is modulus. चलो कोई बात नहीं. He is asking this area to this area. कैसे करेंगे सर? किसी को आंसर आया? Only Vaibhav Patil has given the right answer. Very good sir. Only कैसे करेंगे सर? ध्यान से सुनो. Young's modulus is given as 4.5 gigapascal. Can I write this Young's modulus as 4.5 into 10 power 3 megapascal? Because I am converting gigapascal to megapascal. I am converting giga को mega में convert कर रहा हूं. So therefore it is 10 power 3 megapascal. Leave it. Can anyone in the class tell what is the slope of this? Up to elastic limit इसका slope क्या show करेगा? Everyone knows the slope of this is nothing but Young's modulus. What is slope? dy by dx. dy by dx. The slope up to this proportionality or elastic limit is dy. So 450 minus 0 dy is 450. dx is this minus this. So I can calculate. Let this be some epsilon. Can I calculate this be some epsilon? फिर से बता रहा हूं सर. Up to this point ले लेंगे. ये वाला ले लेंगे. Already this is given as 450. I do not know this epsilon value, but I know this slope. This slope is representing Young's modulus. What is the slope? So अगर ये megapascal में है, keep this also in megapascal because slope is dimensionless. So therefore देखो एक बार. तो 450 dy ये length by ये length should be equal to the slope. What is the slope? 4.5 into 10 power 3. This is megapascal. This is megapascal. Therefore it is dimensionless. Can you give me the value of epsilon? तो कितना आएगा सर? कितना आ रहा है सर ये? यार मैं भी पागल हो गया आपकी तरह. 450 by 45 into 10 power 3.5 ये 10 ऊपर ले जाएंगे तो क्या होगा सर? ये 10 तो 100 मीन्स 0.1 आ रहा है ना? किसी को 0.1 आया? किसी को 0.1 आया? वंडरफुल सर, 0.1. तो ये वाला 0.1 है. वेरी गुड सर. सो जब ये 0.1 है, when this is 0.1, this is 0.1. एक बार मैं इरेज करके बताऊंगा सर. एक बार इरेज करके आपको बताऊंगा. दिस इज 0.1. आराम से, टेंशन मत लेना सर. आराम से, टेंशन मत लेना सर. 0.1. तो अब देखो, This value is 0.1. Great. Already you know this value. How much is this? 450. So I want resilience. Resilience means this area. So triangle का area. Resilience R लिखेंगे. Half into base. What is this base? 0.1 into this height. What is this height? 450. I think you are getting this resilience as कितना आ रहा है सर ये? 22.5. Am I right? Yes. 22.5. Is it correct? Wonderful, sirs. Wonderful. अच्छे students हैं आप. 22.5. कोई दिक्कत नहीं. It's 22.5. Now I want toughness. Toughness is not only this area but also this. अब अगर ये total 0.45 है, what will be this area length? If this total is 0.45, dear students, if this total is 0.45 and this is 0.1, this will be अरे सुनो रे, ये 0.1 है रे और ये 0.45 है. What will be this length? It will be 0.35. तो can I calculate this area? देखो फिर से बता रहा हूं सर, ये वाला एरिया कैलकुलेट करेंगे हम. ये वाला एरिया. What is this vertical length? It is 450. So what is this length, sir? This length. Already this total is 0.45. This is 0.1. So this will be 0.35. So आप calculate करो. 450 into 0.35. But please note down that that is not resilience. Sorry, that is not toughness. So that is giving me only this area. If you want toughness, it will be the total area. This rectangular area plus triangular area will be toughness. So can you tell me what is the rectangular area? It is 450 into 0.35 plus 22.5. So rectangular area is 450 into 0.35. Triangular area is this. So total कितना आ रहा है सर? अरे यार क्या स्टूडेंट्स है रे बाबा. 450 into 0.35 plus 22.5 180 आ रहा है. So the toughness is 180 and the resilience is 22.5. So he's asking ratio. Toughness is 180, resilience is 22.5. So 180 by 22.5. तो कितना आ रहा है? 8. तो मुझे उल्टा चाहिए सर, उल्टा चाहिए. तो उल्टा चाहिए. He is not asking toughness by resilience. He is asking resilience to toughness. That is 22.5 by 180. I think 0.125. Anyone got 0.125? Very good. अच्छा था क्वेश्चन. ठोको ताली एक बार. Is it okay? 1 by 8 or 0.125 is correct. बोलो सर, बोलो. Is it okay? Is it okay? Shall I continue? Very good. 4 questions हो गए कंटिन्यूसली. ये करो सर. अच्छा सवाल है. देखते हैं सर कितने लोग करते हैं इसको. Pradeep has asked one very good question. Sir, can we say flow stress as toughness of the material? Please observe here. Flow stress we study in metal forming. That's a different concept. यहाँ पे toughness में दोनों भी आएंगे. It's something like this, my dear students. Actually, toughness is showing what? Before failure, how much it absorbs. For example, मैं आपको ये लॉजिक बताऊंगा सर. इधर देखो, कास्ट आयरन ले लेना. इट्स ब्रिटल. यहीं पे फेल होगा. अगर माइल्ड स्टील ले लिए, which one is tougher? Which one is tougher? Mild steel or cast iron? Which one is tougher? Mild steel or cast iron? बोलो सर, बोलो. टफनेस का मतलब अप टू फ्रैक्चर व्हाट इज द टोटल एरिया? माइल्ड स्टील. वेरी गुड. इसका फिजिकल मीनिंग क्या है सर? इसका मतलब है बिफोर अ मटेरियल कुड फेल, इट्स समथिंग लाइक दिस. मैं आपको मार रहा हूं. थोड़े स्टूडेंट्स क्या करेंगे? एक दो मारने के बाद सर हो गया मेरा. और थोड़े स्टूडेंट्स मारो मारो मुझे मारो, मारो मुझे मारो. मतलब वो फेल होने तक ज्यादा एब्जॉर्ब कर रहा है. इट इज शोइंग दैट. इज इट ओके? इज इट ओके सर? समझ गए रे? क्लियर रे? क्लियर रे? क्लियर है? अच्छा है. चलो अब अच्छा क्वेश्चन करेंगे हम. देखो, टेक दिस क्वेश्चन. कितना अच्छा क्वेश्चन है. ए रॉड इज लाइक दिस. एक सेकंड रुको सर. रुको जरा, there is a rod. Let the length of this rod be L. Let the diameter of this rod be D. Can you tell me what is the volumetric strain of the rod under uniaxial loading? अगर हम इसको थोड़ा इरेज करेंगे सर आराम से, कोई टेंशन मत लेना. Let the diameter be D. Let it be loaded like this. Can you tell me what is the volume of this? Volume is pi by 4 d square L. I do not know whether you remember or not. मैं क्लास में बताया था आपको, आई हैव टॉट यू वेरी क्लियरली, क्लास में बताया था. निशांत हैज गिवन 0.04. चेक करते हैं. समवन गिव 0.08. 0.08. वाह, अच्छे बच्चे हैं. सो द वॉल्यूमेट्रिक स्ट्रेन इज गिवन बाय 2 times diametral strain plus 1 times longitudinal strain. इसको बोलते हैं axial strain also. Means in the longitudinal direction, lengthwise direction. मैं दिया था, आपको याद नहीं. For sphere, I gave it as 3 times the diametral strain. For a bar subjected to axial loading, the volumetric strain is, अरे क्या डाउट है सर, इसको डिफरेंशिएट करना. अगर आपको डाउट है तो ऐसा करो, इधर देखो. log v is equal to log pi by 4 plus 2 log d plus log l. अरे यार दोनों तरफ log ले लेना. log a b c, log a plus log b plus log c. log a पर m is, इसको लिखूंगा, आप डिफरेंशिएट करो. What is log v? 1 by v dv. 1 by v dv. इसका तो कांस्टेंट है 2 times. What is log d? dd by d plus log l dl by l. This is axial along the longitudinal direction and this is diametral strain. Twice, sir, ये क्वेश्चन भी आता सर. The volumetric strain of a rod subjected to uniaxial loading is 2 times the diametral strain plus axial strain. Is it okay, sir? ये भी क्वेश्चन हो गया, देखो ये भी क्वेश्चन हो गया. वंडरफुल सर. अब देखते हैं सर. Shall I proceed? कुछ नहीं है सर, वेरी सिंपल, वेरी सिंपल, वेरी सिंपल. आराम से, आराम से, कोई टेंशन मत लेना, टेंशन मत लेना सर. वन सेकंड प्लीज, आराम से. What is given? The uniaxial resulting in a strain of defined by uniaxial along the axis, the lengthwise is 0.02 and Poisson's ratio is given as 0.3. Then the volumetric strain is, how do we do this? देखो एक बार. You know the strain, what is Poisson's ratio? It is y direction to the x direction. In this, of course, minus. Yes or no? Of course, minus. Because when the length is increasing, the diameter is decreasing. When the length is increasing, the negative sign shows the opposite sign. Okay? Is it okay? कुछ नहीं बोल रहे. Is it okay? Right. अब देखो. Y direction का मतलब ये कौन सा है सर? Diameter. Y direction का मतलब क्या है सर? ये diameter. X direction का मतलब क्या है? Lengthwise. So what is the strain in the diametral direction? देखो, nu into, of course, minus है, minus epsilon L. So diametral strain is given by minus, what is the Poisson's ratio? 0.3 into length direction में 0.02. ये कितना आ रहा है सर? Diametral direction में the strain is given by minus point. अगर multiply करेंगे तो 6 आएगा, लेकिन 0.12, 0.006. Is it correct? No, I want volumetric strain. So what is volumetric strain? 2 times the diametral strain plus lengthwise. Lengthwise is already given. कितना दिया सर? Lengthwise कितना दिया? 0.02 plus 2 times diametral strain is 0.006. तो कितना आ रहा है सर? Volumetric strain is asked. Is it okay? Is it okay? क्या सर आप कुछ नहीं बोल रहे? Is it okay, my dear students? You're not saying anything. So if you calculate, I'm getting this as 0.008. Is it correct? Is it 0.008? Values आप चेक करना सर. Concept मिल गया सर. Every concept I tried to cover. I'm trying my level best to cover. Is it okay? Okay, clear? Clear? Wonderful, sirs. Let's go to the next question. Wow. Simple question, expected question. Hydrostatic. अब देखो सर्स, फॉर अ स्टैटिक फ्लूइड इज देयर एनी शियर स्ट्रेस? आप देखो, फॉर अ स्टैटिक फ्लूइड इज देयर एनी शियर स्ट्रेस? हाइड्रोस्टैटिक, फील देखो, व्हाट इज अ फ्लूइड विच फ्लोस अंडर द एक्शन ऑफ शियर फोर्स? तो हाइड्रोस्टैटिक, यहां पे देखो, हाइड्रोस्टैटिक मींस नो शियर, शियर शियर, देखो शियर 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 गायब कर देना। अरे सॉरी 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 सॉरी, हो सके तो माफ करना, शियर को गायब करना। नॉर्मल नॉर्मल नॉर्मल, सिग्मा x is 100, sigma y is 125 and sigma z is 75, and you know the hydrostatic stress is nothing but the average stress। कैसे? इधर देखो, एक ब्लॉक है और एक ब्लॉक को हम छोटा सा ब्लॉक ले रहे, सब कर, प्लीज ऑब्जर्व हियर, the top fluid will exert pressure, this side, and this all fluid, let us say this fluid will exert a pressure, this fluid will exert all around, it is same everywhere। अगर आपको सेम चाहिए तो एवरेज ले लेना, it is similar to your bulk modulus। so what is sigma average, my dear friends? sigma average is sigma x plus sigma y plus sigma z by 3। look at carefully, कुछ आ रहा है सर समझ में? थोड़े लोगों को समझ में नहीं आया, मैं दोबारा बताऊंगा सर, सुनो, आई विल एक्सप्लेन अगेन। सवाल में क्या पूछ रहा है सर? What is he asking in the question? What is he asking in the question? The hydrostatic stress बोल रहा है। Hydrostatic stress means same in all directions। For example, यहां पे देखो सर, ये बहुत अच्छा क्वेश्चन है सर, मैं बता रहा हूं, सुनो, वेट वेट वेट, let this be sigma x, मे बी कंप्रेसिव, मे बी टेंशन, जो भी है, let this be sigma y, let this be sigma z। तो आप बताइए, इस सबको मैं एक इक्विवेलेंट में कन्वर्ट करूंगा तो क्या आएगा सर? इफ आई कन्वर्ट एवरीथिंग इनटू इक्विवेलेंट, एंड यू नो वेरी वेल सिग्मा एवरेज, दैट सिग्मा एवरेज विच इज सेम एवरीवेयर इज हाइड्रोस्टैटिक। This sigma average is actually, hydrostatic is nothing but sigma average। So whenever it is static, hydrostatic, for a static fluid there is no shear। shear का तो छोटे, मतलब मैं ये नहीं बोल रहा shear नहीं है, आई एम इंटरेस्टेड इन हाइड्रोस्टैटिक कंडीशन वाला, हाइड्रोस्टैटिक इक्विवेलेंट। तो क्या होगा? तो देखो एक बार, so sigma x, sigma y, sigma z, so 100 plus 125 plus 75 by 3, that is sigma average, or this also known as hydrostatic stress। what is the value of this? कितना आ रहा है सर? 100 आ रहा है। what is the value of this? 100 आ रहा है। is it clear sir? this is also a good question sir, this is also a good question sir। तो आप वर्ड से कंफ्यूज मत होना। whenever he says hydrostatic, that means it is average, sigma average, which is useful in calculating our bulk modulus। तो बल्क मॉडुलस कैलकुलेट करने में, वी आर नॉट एट ऑल, फॉर बल्क मॉडुलस इज चेंज इन वॉल्यूम, विच स्ट्रेस इज रेस्पॉन्सिबल फॉर चेंज इन वॉल्यूम? नॉर्मल। सो दैट्स व्हाई आई टेक नॉर्मल नॉर्मल, बाकी के तो खत्म कर देना। इज इट ओके सर? वाह, मजा आ गया, ठोको एक बार ताली। मजा आया नहीं रे? क्या स्टूडेंट्स है रे, क्या स्टूडेंट्स है रे, वाह। टेक दिस क्वेश्चन, सारे वेराइटीज ले रहा हूं सर, थोड़ा बैठता और बेटा, बहुत दिन हुआ। क्वेश्चन पढ़ो एक बार, पढ़ो रे क्वेश्चन, पढ़ो रे, अरे पढ़ो रे क्वेश्चन, पढ़ो रे। वाह। A tensile specimen was deformed to a, I tried my level best to include all varieties of questions sir। मैं सारे varieties of questions लेने की कोशिश किया, I tried my level best। A tensile specimen was deformed and the true strain is 0.405। सारे points revise हो जाएंगे। The change in the gauge length was, what is the change in length? It is 5 mm। The final gauge length in mm is, ये पूछ रहा है, what is he asking? The final gauge length। Dear students, वो पूछ रहा है final gauge length। आराम से सुनो my dear students, एक बात बताता हूं, in true stress we calculate stresses with respect to that instant area, because taking original, so you may be asking one question, what is true stress sir? It is the resistance to the area at that instant, because when you are loading, the area is changing continuously। But my dear students, in strength of materials, We take engineering stress, engineering strains only. All this I had explained in my regular classes clearly. What is the reason for that? Because the deformations are within elastic, so therefore they are very small and negligible. When the deformations are very small, the change in area is negligible. When the change in area is negligible, my engineering stress and true stress are almost the same. That's why even if you take engineering stress, engineering strain is with original values, original length, original area. So the changes are very negligible. But when we go to metal forming, there is a large plastic deformation. That's why there we use true stress, true strains. Whenever large plastic strains are involved, we go for true stress, true strains. But in strength of materials, our loading is within elastic limit. The change in dimensions are very small. Even if you take engineering stress, engineering strain, the dimensional changes are very negligible and very small. Leave it. Wonderful, sirs. Answers दे रहे बच्चे. बहुत खुश हूं सर मैं आज. बहुत इसलिए खुश हूं कि आपने अच्छे आंसर दे रहे हैं. So what is true strain, sir? मैं क्लास में डिराइव किया था. I have derived. So the true strain is logarithm ln, मतलब log to the base e plus this is engineering strain and this is true strain. How much is true strain given? 0.405 ln 1 plus epsilon. Can anyone tell what is the value of epsilon? कितना आ रहा है सर? Epsilon का वैल्यू कोई दे सकता है? नहीं दे सर, मैं ही मर जाता हूं. मैं ही मर जाता हूं सर. I'll die sir. तो एप्सिलॉन आ रहा है 0.4. वेरी गुड सर. 0.499 आ रहा है. But what is epsilon? It is engineering strain. The engineering strain is given by change in length to the original length. Whenever it is engineering, conventional or nominal, it is original. So you have calculated epsilon and it is, let us round it off to 0.5. कोई problem है sir? Let me take it as 0.5. कोई चिंता नहीं है. Let me take it as 0.5 is equal to dl by, oh, already dl is given and this is given as phi by l naught. Correct now? So what is this value, sir? L naught. So it will be phi by 0.5. Already this phi is in mm. So L naught will be in mm. So L naught कितना आ रहा है sir? 10 mm. But is he asking original length? No. He is asking the final length. And you know, क्या हो रहा है sir? Are these strains positive or negative? Strains are positive. Which strains are positive? Normal strains are positive. Means length is increasing. So final length should be more. So therefore, the change in length is given by final minus original. What is the change in length given? 5 mm. Final. What is the original length given? 10 mm. So therefore, the final length is given by 10 plus 5. It is 15 mm. So I tried my level best to connect various types of questions. तो वेराइटी अच्छा लग रहा है सर आपको? वेराइटी ठीक लग रहा है? बिकॉज पूरे कॉन्सेप्ट्स लेने की कोशिश कर रहा हूं मैं. वेरी गुड. आजाद यादव रे. ये ले लो. सिंपल क्वेश्चन ले लेंगे सर. काय को सिंपल क्वेश्चन? 1 मार्कर क्वेश्चन एक बार सिंपल फ्लो होता है. देखो, द वैल्यू ऑफ पॉइजन्स रेशियो एट विच shear modulus is equal to bulk modulus. Is Poisson's ratio पे shear bulk are same? You know that E is equal to 2 times G into 1 plus nu. This is the relationship between Young's modulus and shear modulus. And the Young's modulus is also given by 3 times bulk modulus into 1 minus 2 nu. Is it correct, sir? क्या ये सही है गलत है? मैं भूल गया सर. क्या ये सही है गलत है? Should be correct. And this is giving me E, this is giving me E. दोनों को equate करना. So 2g into 1 plus nu is equal to 3k into 1 minus 2 nu. But clearly he said g and k are same. So g, k दोनों बराबर दिया है, इसलिए मैं दोनों को कैंसिल कर रहा हूं. 2 को अंदर ले लेना. यहां पे g गया. 2 into 1 is 2 plus 2 into nu is 2 nu is equal to 3 into 1 is 3 minus 3 into 2 is 6 nu. तो अब ये 6 को इधर लाना. Minus 6 nu plus 2 nu is 8 nu. और इसको इधर लाना और इसको उधर फेंकना. 3 minus 2 is 1. तो nu is equal to 1 by 8. So why I have given this question? There is a reason. Sometimes questions are coming on relationship between various elastic constants. Is it okay, sirs? चलो ये ले लो, करो. 9th. वाह. 9th है ना, 9th करो। एक काम करते हैं सर, अभी मैं क्या करता हूं ना, एक सेकंड, एक सेकंड। सो अभी मैं स्टॉप करूंगा इसको। टुमारो एक्चुअली आई हैव टू ट्रैवल, कल नहीं लूंगा, परसों से अगेन 7 o'clock आई टेक। इज इट ओके सर? इज इट ओके? परसों मैं क्या करूंगा ना, ये क्वेश्चंस करने के बाद कॉलम्स का चैप्टर लेके थ्योरी आई कंप्लीट, देन क्वेश्चंस कॉलम्स का कंप्लीट कर देंगे। इज इट ओके सर? इज इट ओके? लेट्स नॉट ओवरलोड आवरसेल्व्स। मतलब 10-10 घंटे, 15-15 घंटे लाइन स्क्रीन पे क्लासेस, आई डोंट रिकमेंड दैट। इज इट ओके? कल मैं नहीं ले रहा हूं सर, टुमारो आई एम नॉट टेकिंग, तो परसों 7 बजे मैं ले लूंगा। इज इट ओके? डे आफ्टर टुमारो 7 o'clock आई विल कंप्लीट दिस क्वेश्चंस, उसके बाद कॉलम्स के अच्छे क्वेश्चंस दूंगा सर, कॉलम्स के। इज इट ओके? ठीक चल रहा है सर? सो डू यू वांट, इज इट ओके? मैकेनिक्स के लिए बहुत मेहनत कर रहा हूं सर, इंजीनियरिंग मैकेनिक्स के लिए बहुत मेहनत कर रहा हूं। सो आई विल नॉट टेल यू नाउ वट एवर यू हैव सीन। तो देखो ये रिवीजन क्लास है, दैट्स व्हाई आई हैव नॉट कवर्ड ईच एंड एवरी पॉइंट, सो प्लीज अंडरस्टैंड, इट्स नॉट अ रेगुलर कंप्लीट क्लास। ओके, तो हम कल नहीं मिल रहे सर, परसों मिल रहे हैं। डे आफ्टर टुमारो वी आर मीटिंग एट 7 o'clock। इज इट ओके? तो आफ्टर कंप्लीटिंग दिस कॉलम्स एंड थिन शेल्स के कुछ अच्छे क्वेश्चंस लेके कंप्लीट करूंगा। स्ट्रेन एनर्जी, शेयर फोर्स, बेंडिंग मोमेंट, अच्छे क्वेश्चंस लेके कंप्लीट करेंगे। इज इट ओके? आज के लिए बस इतना। सेशन ठीक था, कुछ सजेशंस, क्योंकि नो वन इज परफेक्ट इन दिस वर्ल्ड। सजेशंस का मतलब नॉट कंटेंट, मतलब स्पीड या फिर कैसे ऐसा। इज एवरीथिंग फाइन? खुश हो कि नहीं? इज एवरीथिंग फाइन? चलो बाय बाय, थैंक यू, थैंक यू, बाय बाय। अब मैं स्टॉप कर रहा हूं।